So right here, we're going to start on page 14, and we're going to do problem 2F, 2K, and 2L. So let's start. And here we have 2F. And again, here we have an inequality. Same thing holds true as for previous problems. We want to show the values of x that make this inequality true. What are values of x that make 5 less than or equal to 1 minus twice x less than or equal to 11? So in order to solve this, what we really want is to transform this so that in the middle here we only have x. We don't want this number here, and we don't want this coefficient here. So we're going to put the number x right in the middle, and we're going to probably, this number is going to change, and this number is going to change. So we're going to have a number here, then we're going to have a variable x, and then we're going to have another number over here. So how do we do that? First thing, I want to get rid of this 1 here. So if I want to get rid of this 1, I'm going to subtract 1 from the 5, minus 1 from the middle term, and minus 1 from this term. So from each one of these terms, I'm subtracting 1. And if I subtract 1 from 5, I get 4. If I subtract 1 from 11, I get 10. And I also knock out the 1 here. So 1 minus 1 becomes 0, and I'm left with minus 2x. So here, now, I want to get x by itself. How do I transform minus 2x into x? I divide through by minus 2. I divide minus 2x by 2, I get x. I divide this by minus 2. 4 by minus 2, I get minus 2, and 10 by minus 2, I get minus 5. But because I'm dividing through by a negative number, the directions of the inequalities are reversed. So this less than or equal to, and this less than or equal to, become greater than and greater than. So now here is a possible solution. Minus 2 is greater than or equal to x is greater than or equal to minus 5. So I'm saying that minus 2 is the highest number and minus 5 is the lowest number, and that x lies between these two and can possibly equal minus 2 and can equal minus 5. So that is a possibility. So now in this order, just to show you what I'm doing here, I can express this in a slightly different fashion. So in this particular sense, we've written 5 greater than 4 greater than 3. We've gone from the highest number to the lowest number in this inequality. But we could reverse the inequality and say 3 is less than 4 is less than 5. So an alternate notation to this, is to go from the lowest number, which is minus 5, to the highest number, still retaining an equal sign. So what we're saying is that this expression is equivalent to this expression, just like 5 greater than 4 greater than 3 is an alternate way of expressing this is 3 less than 4 less than 5. So here I've expressed the region for which the inequality holds true in terms of descending numbers. The numbers are going down. And here I'm expressing them in terms of ascending numbers. So basically what we're saying is that the boundaries are minus 5 and minus 2, and that the x lies between them. Look at this expression. What does it say? Minus 5 is less than or equal to x. That means that x has to lie over here somewhere, above here, anywhere above here. It can include the minus 5, but it's anywhere above here. The first part, minus 5, is less than or equal to x. But at the same time, x must be less than or equal to minus 2. So I can't keep on going here. I have to stop at minus 2. So we know that the value of x that would fit this inequality is between minus 5 and minus 2, but also includes the minus 5 and the minus 2. We show that with a square bracket. It includes those because there is an equal sign. So here again is the solution set, other than this is the graphical set, but the solution set would be, here's the lowest number, minus 5 right here, that represents this. And then this right here would represent minus 2. Now, you can see that the number minus 4 would lie within the solution set, according to what we've shown. So let's check it out. We'll substitute. We'll take 5 less than or equal to 1 minus 2x less than or equal to 11. And we'll substitute 4 minus 4. Well, 1 minus 2 times minus 4 would be 1 plus 8, which would give us 9. So is 5 less than or equal to 9, less than or equal to 11? And the answer is yes. 5 is less than 9, and 9 is less than 11. So that inequality holds true. So choosing the test number x minus 4 works, and that's what we would expect. Well, let's choose a number that doesn't lie within the solution set. For example, we know that the number must lie between minus 5 and minus 2 and can include minus 5 and minus 2. But minus 1 lies outside of the solution set. It would lie right over here between minus 2 and 0. So now we ask ourselves, go back, substitute minus 1 here. 2 times minus 1 is plus 2. 1 plus 2 is 3. We ask ourselves, is 5 less than or equal to 3 less than equal to 11? Well, certainly 3 is less than or equal to 11, but 5 is not less than 3. So by choosing that point, we have shown a point that outside the inequality, it does not hold true. Now, just to summarize some of the things that I said, if we want to indicate that a variable x lies between two numbers, for example, we want to show that a variable x lies between minus 3 and plus 6, we can write the following notation. We're going from the lower number to the higher number. So the lower number would always be here, right here, and we're going to lie. 3 minus 3 is less than x, and x is less than 6. 6 is the higher number, minus 3 is the lower number. That's one way of representing that a number could lie between minus 3 and 6. For example, if we chose 0, minus 3 is less than 0, and 0 is less than 6. 0 would lie between minus 3 and 6. But we could also write it in, here we're going from the lowest to the highest. Here we could write it in descending order. 6 is greater than x is greater than minus 3. Notice I put the minus 3 over here, and I put the 6 over here. I've reversed it. So we're going from the higher number, greater than x, to the lower number. Okay. For example, here again, if I chose a number between 6 and minus 3, I could choose, for example, 2. Is 6 greater than 2? Yes. Is 2 greater than minus 3? Yes. So we could write it like this. If a is less than x is less than b, then we can reverse the a and b and say b is greater than x, which is greater than a. Now let's go to the number 2k. And again, here we have 1 less than or equal to 3 plus 2/3 x less than or equal to 7. So we're asking, what are the values of x that make this inequality true? And just like the last problem, what we want to do is get a number right here to the left of x and a number to the right of x, and just x by itself. We don't want this 3 plus 2/3 x. The first thing we're going to do is subtract minus 3 from each part of the inequality. So if I do 1, and why do I want to do that? Because if I subtract 3 here, I'm going to get rid of this in this middle term, which is what I want. So 1 minus 3 would give me minus 2. 3 minus 3 would give me 0, so all I get is 2/3 x. And 7 minus 3 would give me 4. So I've shown that right over here. Minus 3, minus 3, minus 3, and I come out with this. Now there's a problem with this expression because this middle part is a fraction. I don't want a fraction. So what I'm going to do is multiply each term by 3/2. This is the reciprocal. Because if I multiply by 3/2, you can see here, I'm going to get rid of the 3 here. I'm going to get rid of the 2 here. And I'm just going to get x. So I'm multiplying each term by 3/2. 3/2 is the reciprocal. In other words, I take the 2 here and I bring it down to the denominator, and I bring the 3 up. That's the reciprocal. So I just reverse the position of the numerator and the denominator. I'm going to multiply each term by 3/2. And the reason I do that is because the 3 will cancel with the 3, the 2 will cancel with the 2, and x will be the only middle term. Well, if I multiply the middle term by 3/2, I have to multiply the left-hand term right here by 3/2, and I have to multiply the right term by 3/2. When I do that, here, the 2 cancels here, and I get minus 3. The 2 cancels with the 2, the 3 cancels with the 3, and I get x. 4 times 3 over 2 is 12 over 2, which is 6. Or I can do 2 into 4 is 2, and 2 times 3 is 6. So now we have minus 3 is less than or equal to x is less than or equal to 6. So we know that x lies between minus 3 and 6, but could include 6 and minus 3. That's a possibility. So there's the solution graph. I can show this with the notation minus 3 here and 6 here, and because it includes these two as equal, it's this. This is the lower number, this is the higher number, and because the solution includes the equal sign right here and right here, we include a square bracket. So we're going to check this answer to see whether it seems correct. So we're going to choose x equals 0 because 0 is right here. It's right in the middle, and it's going to make it easier to do the arithmetic with. So I choose 0, and I put it back into this expression where x is 0 here. So this term will work out to be 0. That's what I mean when I say using x equal to 0 usually makes the operation simple. 2/3 of 0 is 0. So I'm going to be left with 3 here. Is 1 less than or equal to 3? And 3 less than or equal to 7? Yes. So choosing x equal to 0 gives us an answer that makes the equation correct. Let's choose a number that does not fall in the solution set. And the number we're going to choose is minus 4. Minus 4 would be right here. That would not fall within the the solution set. So the equality should not hold when we put it in. So if x equals minus 4, does 1 less than or equal to 3 plus 2/3 of x, and we're going to substitute minus 4 here, less than or equal to 7. We're asking that question. So 2 times minus 4 is minus 8 divided by 3 is minus 8/3. So 1 is this one, 3 is this one. 2 times minus 4 is minus 8 divided by 3 is minus 8/3, less than or equal to 7. Now, what am I going to do about this 3 minus 8/3? Well, what I've got to realize is that 3 is 9 over 3. 3 is 9 over 3. So now, instead of writing 3, I'm going to write 9/3, subtract the 8/3, and I'm left with 1/3. So, is 1 less than or equal to 1/3? No, it isn't. So, therefore, the x equal minus 4 does not fall within the solution set. So, let's go over what we've done here. We found what the values of x that make the original equation true. Right over here, here's the original equation. We found that if x lies between minus 3 and minus 6, and 6 plus 6, and includes those values, that would be a satisfactory value of x for that equation, for this equation right here. We then tested it with a number that fell within the solution set, 0, and then we checked it with a number that didn't fall within the solution set. With using x equals 0, we found that the inequality was still true. Using minus 4, we found that the inequality did not hold. Okay. Problem 2L. And here again, what we want to know is what are the values of x that make this inequality hold true. As we did in the previous problem, what we want to get is x right in the middle here. We don't want this 3, we don't want this 5/2. We want just x by itself, so we're going to need to change this number and this number here. So first of all, let's subtract 3 from each term in this inequality. What I do to one part, I must do to the other. So I'm subtracting 3 from 8, subtracting 3 from the middle term so that the 3 cancels, and then I'm subtracting 3 from 18. So I'm now left with 8 minus 3 is 5. The 3 and the 3 cancel. I'm left with minus 5/2 x, and 18 minus 3 gives me 50. Now I'm going to multiply each term by minus 2/5, because if I multiply by minus 2/5, I'm going to get x here. A minus 2, and this minus will be plus. The 2 cancels with a 2, the 5 cancels with a 5, and I'm going to be left with plus x. Now, remember, when I multiply by 2/5, the direction of the inequality changes here. So this becomes greater than or equal to. This becomes from less than to greater than, because I'm multiplying by a negative quantity. So the direction of the inequality changes. Now, look at the middle term again. The 5 cancels with a 5. The minus and the minus give me a plus, and the 2 cancels with a 2, so I'm left with x. And so we know that minus 2 is greater than or equal to x is greater than or equal to minus 6. And I just need, if I want to, I can find it a little better to write it in this notation, a little easier to understand. Minus 6 is less than or equal to x, less than or equal to minus 2. Each one of these, either whether we use this or whether we use that, gives us So in this case, here the number is between -6 and -2. X can be between 6 and -2, but it can also include the -2 because of this equal sign. The rounded bracket indicates that -6 is not included in the solution set. So here, this is the lower end, this is the higher end, and there's the including equal sign. So this is the solution set, this is the solution graph. Let's check that -4 lies within the solution set. If you look over here, you can see -4 would be about here. So we choose as a number that lies within the solution set. We could choose -5, we could choose -3, so we just chose -4, see if it's going to work. It should work. And then we plug it back into the original equation. 8 less than or equal to 3 minus 5/2 of x, there's the x right here, less than 18. So minus times a minus gives me a plus. 5 times 4 is 20. 20 divided by 2 is 10. So 3 plus 10 is 13. It is 8 less than or equal to 13. Yes. Is 13 less than 18? Yes. So x equal to -4 lies within the solution set. Let's choose a value of x that does not lie within the solution set. If you go back here, 0 you can see doesn't lie in the solution set. So we'll go back and put it in the original equation. 8 less than or equal to 3 minus 5/2 x, here's x equal to 0, less than 18. Well, 5/2 of 0 is 0. 3 minus 0 is 3. Is 8 less than or equal to 3? No, 8's greater than 3. So the inequality doesn't hold when we choose x equal to 0 as part of the solution, and we see that it should. So if we go back over here, let's just review what we did, recapitulate. First of all, what we did was we removed the 3, because we don't want a number there, we just want an x. And then we multiplied this by -2/5 so that we would just have x. And that was part of the problem. Here we've removed the -3. What we do to one part of the inequality, we do to the other. Then we multiplied each part of the inequality by -2/5. Notice how I've written this all out. And from this, we came up with this. We showed that this was equivalent to that. This is written in decreasing order. -2 is greater than or equal to x, and x is greater than -6. If we put this over here and we put that over here, we see that -6 is less than or equal to x, is less than or equal to -2. So here you can see if -6 is less than x, and x is less than or equal to -2, then it must lie in between -6 and -2. And because we're including the -2, we put a square bracket here. And then we just checked with an answer with a number that lay within the solution set and a number that lay outside of the solution set, 0, to verify that we had the right answer. So this completes page